Okay. Now the session is being recording. Okay. So so I think we have done up to some level yesterday, but we will start at the beginning. Okay. So this is discrete memoryless source. Okay. So here we are given some alphabet. Okay. Sometimes we can refer this as symbols. Okay. But it is not, sometimes it is mentioned as symbol. Okay. In this case, we can consider this as a symbol. Okay. But it is not equal with the module. When you are doing the modulation techniques, when you are learning the modulation techniques, you also learn a symbol, no, there. But this is not directly equal to that concept. Okay. So it is better if we can remember this as a alphabet. Okay. Q3. Okay, we will go to the Q3 also. Okay, thanks. Thanks for the feedback. Okay. So so here we have three alphabet: S0, S1, S2, three alphabet. Okay. So sometimes this can referred as symbols also. Okay. So we are given the probability of occurrence of this alphabet. Okay. Of these symbols. Okay. This is 0.7 and this is 0.15 and this is 0.15. Okay. So if you add this probability, you will get 1. No. So sum of all these probabilities should be 1. Okay. So you will get 1. Okay. So yeah. So I think you know how this yesterday I have explained how this probability is calculated. Probability of occurrence is calculated. I hope you have no any doubt with that. Okay. So we will continue. So we will directly come to the Huffman code, Huffman algorithm. Okay. So in a Huffman algorithm, so you know that Huffman algorithm is used to compress data. Okay. So Huffman algorithm, this is a data compressing techniques. Okay. Data compressing technique. Okay. So we use Huffman algorithm to compress the data. Okay. To reduce the bit size of the data. Okay. Okay, so we will see how we can do it. Compressing task. Okay, this compressing task. Okay. So we will directly go to the Huffman algorithm. Okay. So you know that the first step is we have to write the probabilities from highest one to lowest one. That is the first step. Okay. So I will, as a first step, I will do. So you can see that S0 has the highest probability. So I can write it on the top. Okay. And you can see S1 and S2 have 0.15 and 0.15 same probability. So you can write it anyway. S1 and S2. Okay. So this is the probability of S0 and this is the probability of S1 and this is the probability of S15. Okay. So these are the probabilities. Okay. So the next step is we have to add the least two probabilities. In this case, here it is this two. Okay. So we have to add them and again we have to write the probabilities. So if we add this together, you will get 0.3. Okay. So if you add together, you will get 0.3, and it is less than 0.7. No, so still the highest probability is 0.7. Okay, then the second one is 0.3. Okay, so we will reduce in the symbol one by one, or the character one by one. In this case, we have 3 characters. So we should reduce in the character one by one until we get 2 characters. Okay, until we get 2 remaining characters. So here you can see that only we have 3 characters. Okay, 3 characters, 1, 2, 3. Okay, so so if we reduce 1 character, we will get only 2 remaining characters. No, so we have to do one step reduction. Then we will get to we will come to a final stage, that is up to 2 characters. Okay, so if you add this also, you should get 1. Okay, the probability you should get 1. So if you add 0.7 and 0.3, you will get 1. Okay. Okay, so you can see that this 0.7 is moved to here. Okay, and this 0.15, 0.15 add, and it moved to here. Okay. Okay, so now you can assign the bit. Okay, you can assign the bit. Okay, so 2 ways you can assign the bit. Okay, in 2 ways you can assign the bit. Okay, 2 ways you can assign the bit. One way is you can assign the bit only for this addition part. Okay, for example, okay, so here I can't explain it because only 2 steps are there. Okay, so anyway, the one way is you can assign bits only for this addition parts. Okay, addition in parts. Okay, then you will get the code tree, what is called code tree. Okay, and the other one is you can assign the bits at any level. In every level you can assign the bits. Okay, so for example, so anyway, this for the last step, you have to assign the bits. Okay, so you can assign the bit as the here only 2 characters, 2 probabilities are there. So you can you can assign 2 bits. Okay, you can assign 2 bits. So we have 2 bits, 0 and 1. Okay, so 1 probabilities you have to assign 0, and for other probabilities you have assigned to 1. Okay, you have to assign 1. Correct? Did you get it? Okay, so after reducing, we will get at the final stage, we will get only 2 probabilities. Okay, and at final stage, we have to assign the bits for that 2 probabilities. Okay, if we consider the bit, we have only 2 bits now, 0 and 1. Okay, so for 1 probabilities, you have to assign 0, and for other probabilities also, you have to assign 1. Correct? Okay, so here normal way is that higher probabilities we assign 0, and lower probabilities we assign 1. This is the normal way, but you can also assign 1 and 0. No problem. If you assign 1 and 0, your code word will be changed. Okay, code word means, you know the code word. Code word means somehow we assign some value here for this S0, S1 and S2. Okay, so that bit stream is the code word. No, okay. Let me tell you another thing. Okay, so here you have 3 characters. No, S0, S1, S2. Okay, so there are 3 characters. Okay, so if you want to assign bits to each characters, how many bits you have to use? Can someone feedback? If you are directly, so without using Huffman codes or other things, okay, you want to assign some bits to these three characters to identify these three characters, okay. So how many bits you should assign for one character? Can anyone tell? Yes, very good. We have to assign 2 bits, no? Yes, we have to assign 2 bits. Okay. So for example, okay, we can, so if we have 2 bits, we can have four proper four different combination, that is 0 0 0 0 1 1 0 and 1 1. Okay, we have 4, we will have 4 different combination, bit combination, and out of these 4 you can assign 3 combination for these 3 characters, no? Okay, so this is without Huffman coding. Okay, so directly we assign some bits to identify this character. Okay, to identify these characters, we have directly assigned some bits. Okay, so we have used 2 bits. Okay, so code word for S0 in this case is 0 0, and code word for S1 is 0 1, and code word for S2 is 1 0. Okay, so this is the code word. Okay, so these are the code word if we directly assign the bits. Okay, and of course you can assign another bits, 0 1 1 1 1 0, like that. Okay, so anyway, it is a feature of your system. Okay, so you can assign any bits. Okay, so these are defined in protocols, no? So you know that we need protocols to communicate. Due to this, we need to have agreement. So these agreements is the protocols, no? So in protocols we can define this bits value. Okay, bits combination. Okay, so so we will move to this one. Okay, so what I want to tell you is that if you assign 1 for higher probability and 0 for higher probability, you will get different combination of code word. Okay, but it will not affect your system. Okay, still you will get the efficiency, same efficiency. Okay, and the code word length, the what is that called, the average code word length, you will get the same value, and efficiency you will get the same value. Okay, 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 so I hope you get it. If you have any problem, you can ask me. Okay, so I am not going actually here, I am trying to do this question. Okay, so I am not going in a formal way. Okay, so if you have any confusion or anything, you can ask me. Okay, if you have any clarification, you can ask me. Okay, okay, okay. As usual, I will assign 0 and 1. Okay, 0 and 1 here. Okay, so you can see that here the 1, here this 0, we assign 0 for this 0.7 probabilities. Okay, and this 0.7 probabilities is shift directly from here. Okay, so this 0 also can be assigned to this part also. Okay, for these probabilities also. So this probability is directly related with S0. Okay, so we can assign 0 for S0. Okay, we can assign 0 for S0. Okay, and you can see that if you see this 1, okay, if we assign this 1 to 0.3 probabilities, okay, 0.3 probabilities, this 3.3 probabilities formed by adding these 2 probabilities, no, these 2 probabilities. Okay, so this 1 should be assigned to both probabilities. Okay, so I assign 1 and 1 here. Okay. So you can see that here another step is there. Okay. So here also you have to add another bits after this bit. Okay. So here I assign 0 and 1. In same way, I assign 0 and 1 here. Okay. You can interchange this value. Okay. 1 and 0 you can assign. No problem. You will get different combination. You can get different combination. No? Am I right? As in this case, you can get different combination. No? So there are four probability. So four combination, you can assign any combination here. Okay. And here also you can do the same thing. Okay. Okay. So here 1 0 and 1 1. Okay. And you can see that this 0.15, the bit is 1 0 we assign, and for this probability 0 and 1 5 we assign 1 1. Okay. So you can see that this probability is directly related with the S1 symbol, and this probability is directly related with S2 symbol. Okay, so I can assign 1 0 and 1 1 for these three characters. Okay, so this is the assigning. Actually, I used to do in this way. Okay, I used to assign the bits. Okay, also you can use the code tree here. Okay, uh, actually I am not very much familiar with that one. Okay, but here only three symbols are there. No, so we can assign the we can use the tree also here. Okay, so here you can get here 0.7 and 0.3, and you assign 0 and 1 here. Okay, and so this is directly related with 0, and here you will get 1 and 0. Okay, so you will get 1 here. Okay, and also for this so here only combination. So here the probabilities are adding. So for this addition also we have to assign some bits. Okay, so here I assign 0 and 1. Here also I assign 0 and 1. Okay, so this is the code tree actually. Okay, so very simply we can do this one. I think I can't. So anyway, I used to do this way. Okay, but this also seems somewhat easy. Okay, so anyway, in your class, in your theory class, okay, what is the procedure you are taught? This one, assigning the bit or using the code tree. This one. Second one, no? Okay. Okay, then we will use the second one. Okay. Actually, for more, when we are dealing with the big, uh, when we are dealing with large symbols, large number of characters, sometimes I feel that this method is sometimes confusion. Okay, so anyway we will use this one. Okay, otherwise you will get confusion. No, if you used to do in this way you will get confusion. Okay, okay, so we will try to follow this one. Okay, so if I done any mistake, you can ask me, you can tell me. Okay, so here also if you assign the code tree, okay, you have to read the bits in this way. No, as I can remember, you have to read the bit in this way. So here for S0 it is 0, and for S1 it is 1 0, and here S2 it is 1 1. Correct? Here also we get the same value. Okay, so I hope it is correct. You have to read it from this side. 0 1 0 1 1. Am I right? Are you reading the code from this side, from the inside? Can anyone tell? Can anyone feedback? Yes, thank you. And I think if you read it from this side also, it will not affect, okay? And in your protocols, you have to define it. This is how you're going to decode the, so you have to write some code for Huffman codes, no? That is a protocol, no? Wait. Okay. Okay. So if you read it in this way also, it will not affect it, okay? But when you define the protocol, you have to assign this. I am reading the value from this end to this end. When you are coding, when you are decoding, you have to use the same step, okay? You have to do the same agreement, same standard, okay? Then you will not face a problem, okay? So you can see that sometime there can be different solution, okay? For one question, there can be different solution. That is what I want to tell you, okay? There can be different code words, but all code words are okay if you have, if you are using a proper technique, okay? If you are using a proper protocols or proper standards, all code will be okay. Okay, you can decode the signal using any code. Okay, understand? I hope you get it. Okay, and I hope you have also studied them in your theoretical class also. Okay, okay. So anyway, we will move to the next one. Okay, so here we have to find the average code word length. Okay, average code word length. Okay, uh, okay. So when we are dealing with Huffman codes, okay, I think two parameters, there are two parameters, very important two parameters. One is this, okay, one is this average code word length, okay, average code word length, okay, length, I denote it using elba, okay. And other thing is efficiency. Actually, if you are using any codes, block codes or error correction codes, error detection codes, or these compression codes, or maybe you are using codes for multiple access techniques also, okay. In any case, this efficiency is very important parameter, okay. And in different techniques, we used to measure the efficiency in different ways. So you have to keep remember, okay. So efficiency is normally denoted using meter, no? This with this symbol, okay. So I think you can remember the uh, expression for average code word length and efficiency. For average code word length, it is LK PK, no? This is the average code word length. Okay, LK means the specific code length, and PK is uh, corresponding probability. Okay, we will see when we are calculating the length, you will get it clearly. Okay, and the efficiency is the entropy divided by L bar. No, this is the efficiency. Okay, and here also to find the efficiency, you have to find the entropy also. Okay, so anyone can remember the expression for entropy? I can't remember actually. It is minus someone. Can anyone tell? Okay, we will. I can't remember the expression for entropy. Maybe that tutorial answer in answer sheet we are given, no? Yes, thank you. P log 2. Yeah, yeah, yeah. Please. Okay, thank you. Okay, so it is pk log log 2, no, log 2. uh, Here you can, if I put the minus value here, we have to write pk. Okay, and it is also equal to pk. So this, if we get this minus inside, this will be minus 1, pk minus 1. Then you can also write it as log 2 1 by pk. Okay, so this is the expression for entropy. Okay, you are learning this in information theory, no? Yeah, information theory parts, you will learn this entropy. There are many terms, no? Okay, so I think these are the most important expression for when we are dealing with Huffman code. So please try to remember these things. Okay, you have to use this, and you have to use these terms in your exam also. Okay, so here we want to calculate the average code word length. Okay, so that is L bar is equal to sigma LKPK. Okay, so we have K from 0 to 3, no, 0 to 2 actually. Okay, 0 to 2. So we have so if we expand this, we will get L1 P1 plus, sorry, L0 P0 plus L1 P1 plus L2 P2. Okay, so this L0 is 0 word code length. Okay, so if I write it here, our code after using Huffman code, as I can remember, we assign 1 0 here, 1 1 here, no, 0 1 0 1 1 here. Okay, so what is the code length for this symbol? What is the code length for this symbol? It is 1, no, because only one bit is there. Number of bit, code length is number of bit. Here this denote the number of bit, number of bits of the specific code word. Okay, specific code word. Okay, so here you have one number of bits. Okay, so here L naught is 1, and what is the probability for this specific symbol? That is 0.7, no, and in this case it is 0.15, and in this case it is 0.15. So you will have 0.7 here plus L1, that means S1 code length. Okay, code word length, that is 2 bits there. So the length of the code word is 2 bits. Okay, so here 2 0.15 plus, for S2 also there are 2 bits, no, so code length here also will be 2, and the probability will be 0.15. Okay, so 0.7 0.3 0.3, you will get 0.6 here, so you will get 1.3. Okay, bits per character. Okay, character. As I can see it here, it mentioned as symbols, no, bit per symbols. So symbols word also is okay. Okay, so you can use this symbol terms. Okay, so it is 1.3 bits per symbol or character. Okay, yeah, no, we have to show this one, and so this one is okay. Okay, so we want to extend the source code to order 2. Okay, I think in here also the same thing, no, someone asked to explain the question 3. So in question 3, okay. So here also the same thing, I think, I hope. Okay. So we have to increase the order of the source. Okay. We can increase the order. We have to increase the order of the source as much as possible. I think that is what it means. Okay. So here I will explain it. What is the order of the order of the source? Okay. So order of the source means so I think you know the order of the modulation, no? Can you remember order of the modulation? If you going for higher order modulation, you assign several bits, the higher bits to one symbol. Okay, this is in modulation. So you assign one different bit for uh, the higher number of bits for one symbol. Okay, for example, if you use binary modulation scheme, that means binary phase shift gain, binary FSK. Okay, you assign 0 and 1 for symbol. Okay, so if you going to 4 BPSK or 4 QPSK, that means the order of the modulation is 4. So you assign 2 bits per one symbol. Okay, can you remember? Here, when we are, so in modulation, if it is related to modulation, if we are going for higher modulation, we can assign higher number of bits for each symbols. Okay, and the same concept is there. Okay, same concept is here. Okay, now here we have three characters. No, we have three characters: S1, S2. Okay, so we can go for higher order by combining these characters. Okay, by combining these characters. So we have three characters. Then if we combine this in with two order, that means we will use two characters per symbol. Okay, we will do we will use two characters. Okay, so here S0, S1, and also we can use S1, S2, and also S2, S2. Okay, and the other side also we will get S1, S0, S1, S2, S1, S1, so on. Okay, so I hope we will get 9 combination. Okay, so you can see that this is one symbol actually. This is one symbol. That is why I told you, that is why I tell you, it is better to consider this as characters. Okay, don't get confused. Okay, anyway, don't get confused. Okay, so you can consider this as a symbol in this case and this as a symbol in this order 2 case. Okay, you get it? Did you get it? Okay, order 2, we have to extend it up to order 2. So someone tell me, if we want to move this to the highest order, what is that order? If we move this to a highest order, what is the order we can? Someone can tell? Yes, it is up to order 3, no? Because only 3 symbols we have. Okay, so we can extend it up to maximum up to 3 order. That means we can combine three characters together. Okay, so this is the highest order we can get. Okay, and here also we will get a different combination. Okay, we will get S0, S1, S2, and S1, S0, S2, S2, S1, S2. Likewise, we will get different combination. Okay, okay, okay. Now the problem is that how we find the probabilities for these. Okay, how we find the probabilities for these. Okay, so you can see that if we get at the first time, if we get one of these character, okay, one of these character, okay, we can see there are three characters. Okay, there are three characters. Okay, S0, S1, S2. Okay, so this is your first time. Okay, you pick some you pick a character for first time, then you will get for this character, you will get this character with 0.7 probability, you will get this character with 0.15 probability, and you will get this character also with within 1.5 probability. Okay, so higher order means you will get you have to use you have to pick two symbols. No, so here also you are going to pick another symbol. Again you will get three option. Okay, you will get three option, and it is S0, S1, S2, and this S0 will be 0.7, S1 will be 0.15, this N1 also will be S15. And if you pick S1 at first, then you will have at the second time you will have again three option, S0, S1, S2. Okay, and here also if you pick S2 first, you will get again three symbols, three options to pick. Okay, so these nines are the you will get 9 combination. This ninth combination are the are all the combination for our system. Okay, so how to calculate this S1, S2, S0, S1 probability, or S1, S2 probability? Also we have S0, S0 probability, how to calculate? So this is actually by multiplying probabilities. No? So we can simply multiply the probability. So if you want to find the probabilities through this path, okay, through this path, okay, actually here if you are going to find the probabilities through this path, I think you can remember the set theory. Okay, we find the probability P, this part and this part, P S naught and P S naught. Okay, can you remember? So if we have AB like this, and if you have CD, okay, so if you are going to find the probability in this way, you are going to measure A and C. Okay, P, A, and C. Okay, so I think you can remember that P, A, and C is equal to P, A, okay, and P, C if A get. Okay, so here this probability is the conditional probability P, C, A. Okay, after A, then what is the probability we can get C? If we get A, then what is the probability of C? This is denoted by PCA, that is the conditional probability, no? PCA. Okay, so you can see that if these events are exclusive, not exclusive, no, it is independent. If these events are independent, okay, you can see that PA minus C can be denoted as PA PC. Okay, and you remember PA PC. Okay, so you will get directly, if these are independent, this will PA and PC, not the conditional probability here. Okay. So you can directly multiply. So you know that this one and this one are independent. This first event and this first the second events both are independent. So you can just multiply the probabilities. Okay. If these are not independent, you have to use the condition probability here. It is come through this, no? AC is equal to PAC PC. Okay. And if this is independent, it is PA PC. Okay. And also PC. Okay. So PC cut out. So you can get PAC is equal to PA. Okay. Can you remember these things? Okay. So anyway, if you can't remember this, it is better to keep the idea on this. Okay. Because sometime this system may not be independent. Okay, this pickup may not be independent at this time. You have to consider these things also. Okay, but anyway, if you can't remember those things, it is okay. Okay. So anyway, to find, so now you can see that this event 1 and 2 are independent. So you can get P S naught and S naught by directly multiplying PS naught into PS naught. Okay, so what is the probability here? 0.7 into 0.7, that means 0.49. No, okay. So if you going through this branch, it is S naught S1, no? So P S naught S1. So it will be P S naught into P S1. So P S naught is 0.7, PS1 is 0.15. So what is the value here? Here it is 571, and here it is 3, it is 10, no? So it will be 0.105, no? Correct? If I do any mistake, please ask me, okay? Please tell me. Please try to do this with me, okay? I hope you have a pen and papers, okay? So please doing this with me, okay? Then if I do any mistake, you can correct me, okay? Okay, so please try to do this with me, okay? So I think this is okay. 7, here it is 35, so I put 5 here, and 7 1, 7 into 1, that is 7. 7 plus 3, it is 105. Yes, correct. Okay, thank you. Okay, and also we can find the other probabilities also. Okay, so so this is not the case. We have to find, we have to apply the Huffman codes here. Okay, so if I write, okay, if I write, I will get S naught S naught, no, then I will get S naught S1. Okay, you can see that first S naught S naught S naught S naught S1 S naught S2. Okay, so I will get S naught S2 here. Okay, so we will first write the probabilities, then we will sort it. Okay, otherwise we will get confused. Okay, so again we have S1 S0 S1 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 S2. Okay, and also we have, if we first guess the S2, then we have S0 S1 S2. These are the combination. No? So here it is 0.49, and here it is 0.105. Here it is 0.105 also. Okay, and here S1 is 0.15, no, and S0 is 0.15. This in this branch. This is this branch. Okay. So here it is P S1 and S0. Okay. So here PS1, PS0, PS1 is 0.15, PS0 is 7.7. So we will get 0.150 itself. No, please do this with me, and if I do any mistake, please tell me. Okay. So I hope this is same. And S1, I think we get another one. No, so that means this part. Okay, that means we will get S1. That means S1 is 0.15, S1 again 0.15. So we will get 0.555, 225, and we have to leave one, no, 3 decimal places, 4 decimal places. So it is, yes, thank you, 0.022. Yeah, 0.0225. Okay, and this one also 0.0225. I hope this one will be changed, no, because this is 0.9, so it will be S2 is 0.5, so you will get 0.105, no, correct? Yes, 0.105, and here you will get 0.005, 0.005. Okay, so if I if I order this again, so here is not correct, then S not S1, S0, S2, okay, S0, S2, which one? 0. This last one, no? I hope the, you are telling about, yeah, sorry, this is 0.025. Thank you. Yeah, thank you. 0.025. Okay. So here, so anyone has a problem? So S0, 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 S1, S0, S2. Here we also have S1, S0, no, S1, S0, and S2, S0 should be here, correct? Because this is much higher, in higher probability, S2, S0. Okay, and here we have, so we are here, no? Here we have S1, S1. Okay, and here we have S1, S2. S2, S0 we have moved. Okay, so we have S2, S1, S2, S1, S2, S2. Okay, so if you have done this in the home, okay, maybe this order may be changed. Okay, because these three can be changed as we like. Okay, these three can be moved. Okay, so my answer will not get for you. Okay, it is okay, but if we calculate the code length and the efficiency, the answer should be same. Here the answer should, for this one, answer should be same, but for this assign in code word, answers can be changed. Okay, so we will have different code words. Okay, we will have different code words, but if we calculate the average code word length and efficiency, the answer should be same here. Okay, so please remember that. So if you may not get the values here I get, it is not an issue of yours. Okay, so both can be both answers will be okay. Okay, so here 0.9, 0.105, 0.105, 0.105. Okay, and here we have 0.025, correct? Oh, no. This is also here we have 0.49, okay, 0.105, 0.105, and also this one is 0.105, and this one also 0.105, no, correct? 105, and we will have 0.0225, 0.0225, 0.0225, and here also we will have 0.0225. So we will have 0.491 terms, and we have 105, 1, 2, 3, 4 terms, 1, 2, 3, 4 terms, and others 4 terms will be 0.0225, 1, 2, 3, 4, 1, 2, 3, 4. So I hope this is correct. Okay. So what is the next thing we have to do? We have to add this the least two probabilities. No, we have to at these two probabilities and place it here in somewhere. But this order also should be in highest to lowest. Okay. So if you add these two, so I add these two. I will write it here again. Okay. So we have the so this is very boring, no? So if you don't need to do this, you can skip, okay? But sometime maybe you have to concern the other attitude also, okay? Because some student may not be uh, familiar with this, okay? If they do not do the homeworks, okay, they will not familiar. So I will do this. It's not S1, it's not S2. Here it is also S1 is not S1, S1, okay, and S1, S2, and another again we have S1, S2, S not, S not, S not, S1, S not, S2, S1, S not, S here S2, S not should be here, no? S2, S not should be here, okay. S not, S2 should be here. Then we have S1, 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 S2, S2, S1. So if I'm doing any mistake, please ask, okay? S2, 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 okay? S2, okay? So the probabilities are, this will be 0.49, this will be 0.105, this will be 0.105, this will be 0.105, and also this will be 105, correct? And after that, we will get after that we will get 0.225, 0.0225, 0.0225, 0.0225, correct? Okay. So if I'm doing any mistake, please ask. Okay. Otherwise, we will we will continue our mistakes further. Okay. So please ask if I'm doing any mistake as soon as possible if you get it. Okay. So here, these are the two least probabilities. So I add them. Okay. So I will get 0.0445. Okay, 0.0445 means it is come up to this level, no? So if I add these two, it will move here. No? It will be 0.04, sorry, 45, no? 0.45, correct? 0.054, yeah, 0.045. Okay, then I can write the other probabilities. Okay, so this is directly here, 0.49, and this is directly here, 0.105. This is directly here, 0.105, and this also directly here, 0.105, and this also directly here, 0.105. Okay, and this will move to here, no? Instead of this one, we have to put this one because these two are higher than this one. Okay, so these two we have to put here. Okay, then we have to move this one here, no? 0.0225, correct? And also this one we will write here. So this is directly here, 0. Is it okay? Okay, no? Correct? Like this. Okay. So again we add these two. Again we add these two. Okay. And it will be 0.05. Okay. Wait. Okay. So here 0.225, 0.225. Okay. So if I add them together, I will get 0.045. So I can put it here now. So this will be moved to this here. Okay. 0.045. And others are not shifting in this case. Okay. I can write it as it is. Okay. So if I am doing any mistake, please ask. Okay. I'm just doing. Okay. If I'm doing any mistake, you can ask. Okay. Then we have got these two. So we will get 0.01. No? Yeah, 0.09. Sorry, 0.09. 0.09 means still it is here. No. If you add these two, you will get 0.09. Okay, and this is the lowest again. So this we don't need to remove this. We no need to replace this. Okay, we can write it as it is. Sorry, yeah, I'm doing a mistake. This is 49. Okay, and also this is 49. Please be with me. Okay, otherwise our answer may be wrong. Okay, 0.5 and here also 0.105. Okay, correct. So if I add these two, okay, so it may be I'm not doing any mistake here, no? Okay, I hope I am not doing. Okay, now I add these two. Okay, now I add these two. Okay, what happened? It is 0.195. Now it is moving here, no? Now it is moving here. So I think in the paper you can do this clearly than me. Okay. Sometimes it is hard to write this kind of data using the pad. Okay. So here I have 0.105, 0.009. So if I add them together, I will get 0.195. 0.195. Why I put it here? Because it is higher than 0.105. Okay, so this is not replaced. Okay, so this will be same. Okay, but others will be moved. No, so this will be moved to here now. Correct? 0.105, and this will move to here. 0.105, and also this will be moved to here. 0.105. Correct? Okay. I'm doing any mistake. Let's see it finally, no? Whether I'm doing a mistake or not. Okay, so we will continue. Okay, if I am doing a mistake, it is only addition or subtraction, addition mistake. Okay. Okay. So I don't think you will get this kind of higher, the higher higher order combinations case. Okay, you will get up to 4 or 5 case. Okay, 3, 4, 5 you will get for your exam. Okay, but please practice this, then you can do anything, no? Okay, so again I add this 2. Okay, if I add this 2, what happened? It will be, now it will be 2, 1. Okay, so it is move here. No, it is move here because it is 0, 1, 2. Okay, 0.21. Correct? This not will move here. 49 will be there. So here it is 0.21. So this one will again move. 0.195. This will move. 0.105. That's all, no? Okay. So this will move like this. Okay. So if you add this two again, if you add this two again, what is the value you will get? Okay. So here you will get 59295, no? Okay. So it is shifted to here. I'm doing a mistake here. Okay. So it is shifted to here. 0195, 0105. Okay. And here it is 55. It will be 0. And it is 9. It will be 0 here, 3. Yeah, yeah. Yeah, points. Thank you. Okay. So it will move here, no? It will move here. 0.3. Okay. And this will be 0.49. Okay. This will be 0.49 and it move here 0.3. Okay. And this will shift to here 0.21. Correct? Okay. Then if I add these two, okay, these two, I will get 5.1. Okay. That means it move here at this time. Okay. So here it is 0.51. Okay. And here you will get 0.49. And finally, you can verify that your addition is okay by adding these two. If you add these two, you will get 1. So here, if you add these two, you will get 1, no? So your addition is correct up to here, up to this level. Okay. So, and this is move here. Okay. So now we have to assign the bit. Okay. So we put 0, 1 here. Okay. 0, 1 here. And you can see that. So I think code tree is somewhat easy actually. Okay. In this case also code tree, using the code tree is all much easy. So here it is 1. Here it is 1 up to here. So S note will be assigned with 1. Okay. With 1. Okay. And here also we have to assign 0, 1. 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 Here also 0, 1. Here also 0, 1. Correct? Okay. Now we have to go through this branch up to here. Okay. We have to come from this end up to this end. Okay. So this is already finished. Okay. Now I try to reach this point. Okay. I try to reach S0, S1 from this end. So first I will get 0, then I will get 0. Okay. So I will get 0, 0. Okay. So that is the place where I get confused. Okay. So 0, 0. Now, now here it is 0, 1. No. So I will come in this way. No. So I think that is easy. Okay. So here this part is like this. Okay. I mean this way, this way, this way, and this way. Okay. And this way, and this way, and this way. Okay. Up to this way. No. Okay. Correct. So it will be 0, 0. Okay. 0, 0. And again it will be 0. Okay. So it will be 0, 0. In this also will be 0. And here there is no one. No? So the third one will be 0, 0, 0. Correct? So if I'm doing any mistake, you can ask me. Okay. So I hope it is 0, 0, 0. Okay. So let's follow a path from this side. Mistake. Okay. Okay. Okay, 0, 0, 0. Okay, and if you want to find this one, you have to follow this path. Okay, you have to follow this path. 0, 0, 1. Let's see. Here, yes. Oh no, so from 0. No? We start from 0. No? Any mistake we have done? So I got the change. It is 0 0.001. So you have to start from here. No? S0, S1, 0, 0, 1. Okay, let's check it again. Okay, so anyway, I will try to find the method. I will get some. I will try to find the error. Okay, I will. Sometime my writing pad is not working. Please give me a moment. Please wait. My writing pad is not working. I will change the cable. Maybe it is a cable issue. It's disconnected sometime. Charger එක ගහලා තිබ්බ cable එක. Yeah, now it is okay. Okay, so this is 0, 1. Okay. Here we get 0, no? Let's what is the value here? You said that it should be it will be 0, 0, 1. Yeah, we have to yeah, 0, 0. 0, yeah, 0, 0, 0, 1. Yeah, this is 1, no? Yeah, this is 1. Sorry. Yeah, thank you. The sixth column should be, this is the sixth column, no? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Yeah. So this should be 1, okay? 0, 1. Yeah, okay. So it will be 0, 0, 1, okay? 0, 0, 1. 0, 0, 1. We have to write it in this way, no? 0, 0, 1, because we are reading in this side. We are going to read with this side. So it will be 0, 0, 1, correct, okay? So this will be 0, 0, 1. And I will follow another path also. I'm not going to follow all the paths, okay? So it will waste our time, okay? So I will follow, let's say, so I will come through this, okay? So we have 0 here, 0 here, okay? And here we have also 0 here. So 0, 0, 0, and it is this path, no? And here again 0, and this will be again 0. So this one. So this will be 0, 0, 0, 0, correct? S2, S0 should be 0, 0, 0, 0. Correct? Have you calculated? So this is, sorry, 1. Yeah, 0, 0, 0, 0, 0. Okay. Then 0, 0. Okay. And here 0, 0, 0, 0. Yeah. This one will be S0, S0 will S0, S2, S0 will be 0, 0, 0. Okay. And so can anyone quickly tell me what are the value we can get here? because we have to calculate L and the efficiency. In this case, the average code length and efficiency. Okay, so I think this is 1 bit. Okay, so this also will be 3 bits. This will be 1 bit. Okay, this also will be, yeah, 1, 2, 3 bits. This also will be 3 bits. Okay, any 3 bits. This is 1, this is 3, and this one will be, again it will be a 3 bit. No, this also will be 3 bit, and this one again it will be a 3 bit. No, this one will be a 4 bit length. Please tell me if I am wrong. Okay, I hope I no need to find all the value here. No, you can come through this arrow. You have to come through this arrow. Okay, and if it is a transition, okay, if it is a transition point or add-in point, okay, you have to add the corresponding bit here. That is the simple way. Okay, yeah, let's see. Okay, then we will find this will be 4. Okay, so we will find this one. Yeah, in this case, here you can see that here it will be 0, 0. This is 0 and 0 and 1. Okay, I will write it 0, 0 and 1. Okay, 0 and 0 and 1. Zero, 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 1, and again it will be 1. Sorry, this one 0, 0, 0, 1. It will be 1, and it is 0, 0. Okay, so this one will be 0, 0, 0, 1, 0, 0. No, okay, so it will be 1, 2, 3, 4, 5, 6 bit. Yeah, 6 bit. So other all I think 6 bit. No, yeah, thank you. Okay, so is this the correct length code word for this one? Please find. Okay, please find it. Okay, actually sometime I'm confusing when I'm go through this tree. I'm confusing. I like to assign the bits. Okay, so if I assign the bit, this will be 0, 1. Okay, this will be 0, 1, and this will be 1. Okay, so here you have 0, 1. Okay, here you have 0, 1. Sorry, here you have you have to assign, so this 0, so both 0, 0 you have to assign, and you have to put 0, 1 here. Okay, then you can see that this 0.2 we will get this 2 by adding this 2, so this will be 0, 0, 0, 1, and you have to add 2 bits 0, 1 here. Okay, likewise you have to add the bits. Okay, so I think if we have more columns, this assigning the bits is somewhat easy. Okay, one want to talk? Okay, I will mute if you don't need to, if you don't need to talk. Okay, I think mistakenly someone's microphones are turned on. That is okay. Okay, it is happened mistakenly. So if you want to talk me, please talk directly. Okay, otherwise I will wait few minutes and mute. Okay. Okay, I hope so this will be our code length. Okay, so to find the average code length, okay, to find the average code length, it should be we have to get the sum of each code length multiplied by its corresponding probability, and we have to get all the summation. Okay, so we have here up to 9, no, 0 to 8, that means. Okay. So we have 0 to 8 value. Okay, so if I get the first one, So this is 1, L1 is 1, and the probability is 0.09. Okay, and this you have 1, 2, 3, 3 is length. Okay, so if I get this one, so length is 3 and the probability is 0.15. Okay, and you have 3 such terms. So I just multiplied it by 3 again. Okay, plus here we have 1 for code length, number of the number of bits in this code length is 4. So it is 4 into 105, 0.1055 plus 6. It will be 0.000025. Okay, and there are 4 such cases. No, so I just multiplied it by 4. Okay, so if you simplify this, you will get maybe. Okay, so S1 maybe okay, let's verify it. Okay, so to find the S1 you have to go through this. No, you have to go through. I will get another color. Okay, you have to go through this. Okay, and you have to come here. Okay, then you have to go through this. Okay, and you come here. Okay, okay, and this 0.9 you have 1. Okay, so you have to go up to here. Okay, then you have to come this side. Okay, and this side, this terms. Okay, and you have to go here. Okay, and here. Okay, so if I write the codes, okay, so here it is 0. Okay, here it is 0, and here it is 1. Okay, and again here it is 1. Okay, and here it is 0. Okay, and here it is 0. Okay, it is so here it is 0 again. Okay, 0 and 0. Correct. Okay, so this will be the code word. No, this one is wrong actually. Correct, this one is okay. 0 0 again it is wrong. No, yeah, you have, yeah, correct. No, you have to write in other way. So you have to write in this way, 0 0 0 0 1 1. No, is it correct? 0 0 0 1 1 0. No, so here if I correct, if I write it other side, it will be C, because you have to read in this way. Okay, you have to read in this way, so it will be 0 0 0 1 1 0. No, so this is the correct one. No, the answer is correct. No, is it okay? Okay, so I think the we get the correct answer. No, for S1 we will have this one. This one is wrong. Okay, I just maybe I have done a mistake. Okay, so it will be 0. Okay, it will be 0, and here this 2 will add it, it will be 0.45, and here it is 1. Okay, so it will be 0 1 1, again 0. Okay, and here it is 0, and here it is 0. So 0, 1, 1, 0, 0, 0, but we have to read it through this side, no? So we will have 0, 0, 0, 1, 1, 0, correct? Okay, thank you. Okay, so what is the value you get here if you find this? Okay, so if you find this, that value should be, it is given, no? It is given and we have to prove it. Okay, so that value should be 1.195, 1.1975. Okay, okay, Q6 I will discuss. Okay, okay, 1.195. Okay, so you will get. Okay, so this one will you will get. Okay, and to find the to find the efficiency, you have to find the uh, find the uh, entropy. Okay, so I think this can be done very easily. It will be pk log 2 pk. Okay, so please try to do this yourself. This is the entropy, and once you calculate the entropy, you can find the neta value. Okay, it will be entropy divided by L bar. Okay, one thing, so here you will get a value for L bar. Okay, here you will get the value for L bar. So what is that? It is for 2 bits, 2 character. Okay, it is for 2 character. So to get the 1 character, you have to divide it by this 2. Okay, then you will get that value, I think. Okay, so after dividing by 2, you should get this value, I hope. Okay, am I right? Anyone has done this? Okay, so when you solve this one, the average total length, you will get the value. Okay, but that value is for 2 bits, 2 character. So to find the 1 character, you have to divide it by 2. Okay, so you will get after dividing, you will get this value. Okay, uh, am I right? I hope I am right. Okay, so I hope you get it. Okay, so we will move to the next one. Okay, otherwise our time will be not enough. I think these are you can calculate using the given condition and given equation. Okay, please get remember in those one. Okay, so I think someone has a problem with the question 3. Okay, so question 3, I think you can do the question 3. Okay, so what you have to do is you can sort the probabilities from highest one to lowest one. Then as usual, you can add the least one and replace it and reducing the probability one by one. After that, you can assign the bit. Okay, so in that way you can do this one also. And I think there is a question. Compute the Huffman code for this source, move in a combined symbol, okay, as high as possible. Okay, that means you have to combine the symbol up to highest order. So you have here 1, 2, 3, 4, 5, 6, 7 bits. Okay, so the highest order is you can combine all these 4, all these 7 into 1. Okay, so the highest order you can go for 7. Okay, here you can go 7. That means you are getting 6 bit at once. So what you have to do is, okay, you have to, I think it is better if you can, if you write this code word. Okay, if you write this tree. Okay, if you write this tree, you have S0, S1, S2, S3, S4, so on. Then you have to get again this one, S0, S1, S2, so on. So you have to draw this up to 7. No, you have to draw this up to 7. Okay, then you have to calculate each value. So you will get higher combination. Okay, higher combination, and there are many probabilities. Then you can solve. Okay, so can you do this by yourself? I think the answers also given. Okay, so I think you can do it now. So what is it means that you can combine the symbol. Okay, you can combine the signal. So in this case, you have 7 symbol and you can combine all the 7 symbol together. Okay, then you have to calculate the value. Okay. So here you will have different combination. Okay, like this. Okay, you will have one combination like S0, S1, S2, S3 up to S6. Again, you will have S1, S0, S2 up to S6. You will have S2, S1, S0 up to 6. Likewise, you will get several combinations. To find each probabilities, you no need to do actually. To find this combination, I think it is better to draw this tree diagram. Okay, otherwise you will not be able to find all the combination. Once the combination you found, you can just multiply each probabilities and get the corresponding probabilities to each symbol at this case. Now this symbol is combined character. So you have combined some characters, 6 characters, and you form one symbol here. Okay, one symbol or one character. Okay, so I hope you can do it. Okay, should I do the question 3 again? So it will get much time. So what is your concern? I hope you can do it, no? Can we move to another one? Okay, I will move. Okay, so if this should be done, okay, it should be solved by me. Okay, so that student, one student asked this question. Okay, so I asked that student, please try to do it by yourself and compare the answer. If you have any doubt, please give me a call or just mail me, then I can help you. Okay, if you can't do this by yourself, I can help. Okay, so we will move to the next one, otherwise our time will be not enough. Okay, so I think this one also we can pass, no, because this also is very simple. You can read from here and write the code word. For this one, the code word will be 0000, no? As low as possible. What that means? As low as procedure means only one symbol. The lowest one is 1. So you can get S0, S1, S2, S3 likewise. Okay. Okay. I think you got it, no? Yeah. Okay, okay, we will move. Okay, I think question 5 also in the same manner. Okay, same way. Okay, so I think it is enough to do the example with the Huffman codes. Okay, Huffman codes. Okay, so then we will go to the error correction. Okay, so I will get. So we will first start with tutorial 3. Okay, in tutorial 3 that question 6 is there. Okay, I have seen it. Okay, so I will start question in tutorial 3 and we can do the question 6 also. So I will do the question 6 definitely. Okay, so this is tutorial 3. Okay, it is regarding with error control coding. Okay, so you can see that this tutorial, so tutorial 1 is related with Huffman codes. Okay, that means data compression techniques. Okay, and this tutorial 2, okay, tutorial 2 and tutorial 3, okay, tutorial 3 will be based on wait, yeah, will be based on error correction. Okay, error correction. And tutorial 2 is related with Hamming code. Tutorial 3 is related with convolution code. Okay, so we will start with convolution code because this is the Hamming code is simple. I think maybe you can manage it with yourself. Okay, so I will do convolution. If we have time, we will do the Hamming code also. Okay. I think you have to check it with Bilankamis, okay? Because I don't have actually I'm not doing this subject, okay? She need to do some tutorial, okay? So that is why I get only this tutorial, okay? So I don't have any idea about the exam actually, okay? So you have to ask from this your madam, the Dilanka madam, okay? So anyway, we will start this correction, okay? And I will start from convolution. If we have time, we will move to the Hamming code also, okay? So let's take 5 break, okay? 5 minutes break and come back, okay? So
I'm joining a break.
Okay. So we will begin at 7, okay?